Oh.
Therefore, I might put it up. I just revised this thing for the next class.
So they are directly admitted?
No, some
Or I
they
need to
joined.
admit everyone?
It might ask for few students who have not
Okay.
joined over here.
Okay.
Other students will.
Okay.
Yeah, I will this. Project I was looking at because we have
Okay, good morning, students. Am I audible to you all? Yes, okay, good morning. Good morning, everyone. Okay, so, yes, okay, good morning, everyone. So, what did you do in the last class? I think I had solved some problems, right? Yes, students? Okay, so before that, I had taught you all defects in the vision. That was two were done. One is myopia, and the next one was hypermetropia. So, can anyone define what is myopia? Short sightedness, yes, correct. But how will you define it? Short sightedness is one more name for myopia. If I ask what is the defect in myopia, what the person can see and what he cannot see, how will you tell that? Yes. Yes, correct. Myopia, what happens? Myopia means nearsightedness. The person can see the near things but not the far things. But in hypermetropia, the exactly reverse case of it. That is, they can see the far off objects very clearly and the near objects they cannot see clearly. So these were the two types. We'll move on to the third type today. Okay. So the third type is, yes, the third type is presbyopia. I hope what I'm writing is visible. Okay, so presbyopia. Now you know what is the meaning of bi. Bi means two. Anything, if you have to take two together, you tell bi. So presbyopia usually occurs in the aged people. Okay, in aged people, what happens? They can't see the far off objects also, the near off objects also over here. But some people can see very near objects but not far off objects. So presbyopia is the combination of both, that is nearsightedness as well as far sightedness. So the reason for this, what is the reason for this? What is the cause? The cause is nothing but aging. Aging means it is occurred in aged people. Why only in them? What happens for them is the cellular muscles. The cellular muscles are weakened over here. So as the age goes on increasing, the cellular muscles also decrease their capacity. Means the flexibility of the cellular muscles is decreased over here. So when there is the decrease in the flexibility, the eyeball cannot be adjusted. That is the lens which is there, it cannot elongate or it cannot compress due to the loss in the elasticity. So for that reason this defect occurs. Now how to correct this defect? This defect can be corrected by using a bifocal lens. Okay, by, yes, anyone was asking something? Even, yes, even convex lenses. It depends on what they can see and what they cannot see. If they can't see both near and far, then they will use bifocal. So depending on the defect it goes. Here what happens, convex also they can use, but mostly they use bifocal. What do you mean by bifocal? Bifocal is the combination of concave as well as convex lens. So the upper part will be having concave and the lower part will be having convex. It is made in such a way that the person can comfortably see both far and as well as near objects. Okay. So this is about presbyopia. I hope all the three defects are clear now. Okay. So now we'll do one activity, okay, over here, which is given in your textbook. Okay. So before going to that activity, we need to little discuss about refraction. So I think already refraction is done for y'all. What do y'all mean by refraction? Bending of light. Correct. Okay. Now what is? Yes, that is also correct. Traveling of away from one medium to another medium. Okay. So refraction through a prism we'll see now. What is refraction of a light through a prism? Okay. So first let me discuss what is prism. Have you all seen prism before? Yes. So how is prism? Let me draw that first. Yes, student? Okay, so this is how the prism appears. Okay, so prism is nothing but an optical instrument and this is made up of glass. So prism, this is a rectangular based prism. So it is having, I'll show you one. So this is a rectangular surface. The second rectangular surface is over here and the third one is over here. So total it is having three rectangular surfaces and two, can you see, these are the two triangular surfaces. Okay, so now we'll study how does refraction happens in prism. Okay, for that I have to place the prism vertically upward. Means this part should be on the paper. Okay, so I will just draw a triangle now, students. Okay, I hope you all will understand if I draw. Is it not visible what I have drawn? Okay, 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 okay. So this is how it is. Now I will place it like this. Means vertically upward. So when I place vertically upward, I will just draw a triangle. Okay, so this is one triangular surface of the prism. Okay, so let me name this as side A, B and C. And this angle, what is this angle called? This angle is called as angle of the prism. Okay, so now we'll see what will happen in refraction. So which medium is this? This is made up of glass. And outside the prism, how it is? Now imagine this green board is your paper and on the paper you all have kept the prism. So here we have air medium and here it is a glass. So the refracted ray, if I incident one ray over here, so it will pass from air medium to glass medium. So let me take one incident ray. Okay, so this PE you can see. Okay, so this PE is the incident ray in which direction? In this way. And students always remember whenever we are drawing diagrams in this and the previous chapter, that is refraction and reflection, always this ray is very necessary. Means you need to show the direction of the ray, in which direction it is going. In case if I don't draw this, there will be no meaning. Okay, so always when we are dealing with refraction, reflection, anytime, always it is mandatory you all indicate the ray. Okay, so at this point refraction happens, so I need to draw a normal over here. So let me draw a normal over here. Okay, so now this is the incident ray in the air medium and it is going to the glass medium. Means it is moving from rarer medium to denser medium, correct? I hope everyone knows the meaning of rarer medium and denser medium. If not, please tell me, I'll clear it out now only. Everyone knows, right? Okay, because that was done in the last chapter. Okay, so it is moving from rarer medium to denser medium. So whenever the light moves from rarer medium to denser medium, it moves towards the normal or away from the normal. It moves towards the normal. Yes, correct. So it has to go like this. Now refraction is happening. So it is moving towards the normal. So let it be like this. Okay, students? Okay, so let it be like this. Now what I will do is, after, actually this has happened now. We can't see this. Okay, the light is being deflected. But can we see that? Can we identify this ray of light on the bend over here? No, right? To understand that, we will do one activity over here. So that is, I will put a nail or a pin over here. I'll just prick a pin, that is notice board pins and all we have, right? So let me prick it over here. One is, so let it this be P and this be Q. So after doing that, what I will do is, from this surface, of the prism, I will try to see these two pins. Okay, I will try to see these two pins and those two pins will be also visible. Okay, after that what I will do is, these two pins are visible in a straight line. I will take two more pins and try to arrange in such a way that all the four pins look in a straight line. Here I will separately draw it. See here. Okay, here already two pins are there, P, Q. Okay, so this is how it will be seen in the prism. Okay, so when you see here, another two pins you will mount over here. Okay, so let those two pins be R and S. Okay, so this is how it appears actually when you see. But when you're pricking those two pins R and S, it will be somewhere over here. Okay, it will be somewhere over here like this. So now when you see, all the four will be in a straight line. But when you see, now are they in a straight line, all the four? Here with this diagram, are they in the straight line? No, right? No. But when you are seeing from this side of the prism, you will see that all these four are in a straight line. Okay. So for that, what I will do is, now this ray only has traveled over here, because taking these two as reference, I have mounted these two pins. So I will draw a line over here like this. Okay, let this line be R and S. So here also refraction has taken place, students. Yes or no? At this point I am asking. Yes? Yes. Okay, here also it has taken place. Why? Because it is now, here it had entered, now here it is coming out. How it is coming out? From the prism to the air medium. So it has been moved from one medium to other medium. But here it is being moved from denser medium to rarer medium. So for that, let me draw one normal. Okay, so this is the normal for this point. Correct? So it has moved out. So this is what this angle, now we will try to name all these angles. Okay. So it has moved like this. So this is actually what happens. Okay. So let me draw the rays over. This actually has happened. Now what we learned from this activity we'll see. So this was the activity done. So now I have to see how much it has refracted and what is the angle. So what is this angle now, students? This is the incident ray. So this angle will be angle of incidence. Correct? Yes? This or this? Think and tell me. This or this? Which? Let me make it as 1 and let me take it as 2. So angle 1 is angle of incidence or angle 2 is angle of incidence? Yes? How many of you will tell it is 1? 1? Okay. So how many of you will tell it is 2? Okay, there are some people who are answering it 2 also. Now I'll tell you, 1 is the correct answer and 2 is the wrong answer. Why I'll tell you. So whenever you measure any angle, we measure with respect to normal. Now where is a normal? Our normal is over here. If I take 2, am I measuring 2 with respect to the normal? Normal is somewhere else only. I am nowhere concerned with normal if I take 2. So 2 is the wrong answer. The correct answer is 1. Why? See, this is a normal and this is the angle of incidence. So this becomes our angle of incidence. Okay? Understood why this? Okay. Now we'll measure angle of, now this is incident. When it enters inside, it has become refraction. So refraction, I should take the above angle or the below angle? Below angle, correct. Why? Because this is the refracted ray and this is our normal. So this is the refracted ray over here. Okay. So I have seen many people getting confused over here only. Always any angle, it should be with respect to the normal only. Okay, students. Now we'll speak about the next angle. Next angle is which? This, right? Okay, so this is the normal and this is one refracted ray. So for this will act as the incident ray. Now what about this angle? So this angle we call it as angle E and that angle E is taken as emergent angle. Okay? So this is called emergent angle. So this was the initial ray, that is the incident ray, and this is the final ray, that is after refraction. So now if you observe, in the same prism, refraction has taken place under 2 points, that is over here and over here. So this will become the emergent ray and this is the refracted ray. Okay, so now we understood what is the angle of incidence and what is the angle of refraction and what is angle of emergence. Okay, now we'll see what is deviation. So what do you mean by deviation? What do you mean by deviation? Okay, I'll tell you what is deviation. Now think. Now this is the actual route how you have to go. Okay, I'll just give you one example. Okay, so this is the actual route. Now suppose you are traveling from one place to another place. You have to go with this route, but due to some obstacle or due to some construction on the road, you are not able to go with this route. What you do after this point, you deviate yourself. Means you take another route. Means what? You are deviating yourself. Means what? Instead of going on the actual path, we are going with some other path. So we have taken a deviation. So you all might have observed when there is construction of roads and going on, they keep a board like, please take a deviation. So what do you mean by deviation? Instead of going in the actual path, we take some other path. Understood what is deviation? Okay. Now we'll see what is deviation over here. So this was our actual incident ray. How it had, for example, now prism was not there over here, right? Prism is not there. So how it would have traveled this incident ray? Like this only? Correct? Yes. But it did not go like that. How it went? Like this. Correct? So to now find what is the deviation, what I do is I extend this line in the backward. Which line? This RS line in the backward direction. So I meet at some point over here. So it is meeting at some point over here. So this point I will name it as G. Okay. So this will act as my angle of deviation. Actually, it had to travel like this, but did it travel like that? No. How it traveled? Like this. So this is angle of deviation. Okay, understood, students? What is angle of deviation over here? Okay, so the main aim of this activity was to find out angle of deviation. Means with if prism is there, so how much it can deviate. Okay, if prism is present over here, how much this incident angle will be refracted and it will change its direction. So we got it. So it will change its direction by this angle. So you can just keep a protractor and measure it. You will understand what is the angle of deviation. Okay? We will not get. We will get. Why we will not get exact? So when we see all these pins are exactly in the line, so we can easily measure this angle of deviation. Actually, we need to do this practical on the paper. If you all do it, no, you all will understand it more better. Okay, so we will get the exact angle. Then there is nothing like we will not get. Okay. Any other doubts regarding this? No, right?
No.
Okay. So I hope this is clear. Now I will just. There are some shortcuts to write this. So we'll see what are those. Okay. Now what do you mean by this? If I write like this. A means if we write like this, that is nothing but this angle, that is angle of prism. Then next, if I write I means it is angle of incident. Okay, correct. Then if I write R, angle of refraction. Refraction. And if I write E, then what it is? Angle of emergence. Correct. And if I write D, what is D? Angle of deviation. Here what we got deviation, right? So that is angle of deviation. So these are some shortcuts used to represent the angles over here. Okay, students? Okay. So this activity what I have done over here, I will send you all one video with this today's class. There I will attach one video practically how they have done it. Okay. So please go through it. You will understand it much better. Any doubts? Please raise up. Second time refracted ray is called emergent ray. Yes. If it goes for second time, then it is called as emergent ray. Okay, no doubts? Okay, students. Okay, see you all in the next class. Bye bye. Okay, bye.